And welcome back, students. Let's go ahead and dive into a new topic here. And this is a kind of a one lesson topic. We're just going to talk briefly about abstract classes. So getting started, in our previous chapter, we've defined a class called the employee and to its derived classes, hourly employee and salaried employee. Of course, we've also done other ones like commissioned employee and stuff like that, but those are the main ones that we kind of focused on. So suppose that we define the class, when we define it, employee, we know we're going to frequently compare employees to see if they have the same pay. So let's say we have employee A and employee B and want to see if they're making the same amount of money. Well, we might add the following method to the class employee. Public boolean, same pay, employee other, return this dot get pay equals other dot get pay. Well, there's a small issue with doing this. All right, and this is the issue comes from adding the method same pay to the class employee. And the method same pay includes an invocation of the method get pay, and the class employee has no get paid method. Moreover, there is no reasonable definition we might give for a get paid method, so that we could add it to the class employee. The only instance variables in the class employee give employee's name and hire date, but give no information about pay. So if we really want to see how we should proceed, let's compare object of the class employee to employees in the real world. We're going to use this using an abstract approach. So every real world employee does have some kind of pay because every real world employee is either typically an hourly employee or a salaried employee. And the two derived classes, hourly employee and salaried employee, each have a get paid method. The problem is that we do not know how to define the get pay method until we know if the employee is either hourly or salaried. Because obviously if you're hourly, it's going to be a very different pay schedule than if you're a salaried employee. Therefore, we would like to postpone the definition of the get paid method and give it only each derived class of the employee class. So we'd like to simply add a note to the employee class that says there will be a method get paid for each employee, but we do not know how it is defined. Now, Java fortunately lets us do exactly what we want. And let's take a look at that. And so the official Java equivalent of our permission to know about method get paid is to make get paid an abstract method. An abstract method has a heading just like any ordinary method, but has no method body. The syntax rules of Java require the modifier abstract and require a semicolon in place of the method body, as illustrated by the following. Public abstract double get pay. Now, if we add this abstract method get pay to the class employee, then we're free to add the method same pay to the class employee. Now, of course, abstract cannot be private because of this. Now, an abstract method is thought of the interface part of the method with the implementation details omitted. Because a private method is normally only a helping method, remember it's just there to assist, and so is not part of the interface for a program using the class. The program doesn't call the method directly. It follows that it does not make sense to have a private abstract method. So therefore, in Java, an abstract method cannot be considered to be private. Now, normally an abstract method is public, but it's also considered to be protected, and the package access for the default is allowed. Now, an abstract method does serve a purpose even if it is not given a full definition. It typically will serve as a placeholder for a method that must be defined in all non-abstract derived classes. Now, note that in the abstract employee class, the method same pay includes invocations of the method get pay. If the method get pay were omitted, this invocation get pay would then be illegal. Now, an abstract method typically serves as a placeholder for a method that will be fully defined in the descendant class. All right, so it's just a placeholder. An abstract method also has a complete method heading with the addition of the modifier abstract. It has no method body but does end with a semicolon in place of a method body. An abstract method can also be private, as we mentioned before. So some quick examples: public abstract double get pay, public abstract void do something, and count. You can also have abstract classes. And when we talk about the classes, this is a class that has at least one abstract method, which is called an abstract class, and in Java must have the modifier abstract added to the class heading. The redefined now abstract class employee is shown in class materials. And I'm just going to pull up real quick here, and you can see this is very similar to what we already have in our employee class from before. However, you can see now we've added the term abstract, so it's public abstract class employee. An abstract class can have any number of abstract methods. An abstract class is a class with one or more abstract methods. In this case, when we're looking here, this is, of course, same pay. We're getting some of our new methods in here. In addition, it can have and typically does other regularly fully defined methods. So that would be, for example, like our getString, getHireDate. These are methods that were copied over directly from our existing employee class below. If a derived class of an abstract class does not give full definitions to all the abstract methods, or if the derived class adds an abstract method, then the derived class is also an abstract class and must include the modifier abstract within the heading. In contrast with the term abstract class, a class with no abstract methods is called a concrete class. So most of our classes that we've been doing up to this point, because they don't have the word abstract in them, are concrete classes. Now we don't need to put the term concrete in there because Java knows if it's not abstract, it has to be concrete. Now a quick pitfall to note is that you cannot create instances of an abstract class. You cannot create objects of them. So you cannot create an abstract class constructor to create an object of the abstract class. So the downfall of creating an abstract class called employee, you can't create an employee object. You can't call an employee named Bob. You can only create objects of the derived classes of the abstract class. So it had to be like an hourly employee named Bob, or a salaried employee named Bob. So for example, the abstract class employee, the following would be illegal. Employee Joe equals new employee. It's illegal because employee is an abstract class. But this is a problem because the object Joe could not correspond to any real-world employee. Any real employee is either hourly or salaried. In the real world, it cannot be just an employee. One must either be an hourly employee or a salaried employee. Still, it's useful to discuss employees in general. Now, so you notice that we have, this is just talking about two types of employees. We do have other ones that we have examples of. So, for example, we, in our labs, have also gone through and made commissioned employees. Usually be another type. You can, of course, if let's say we wanted to take a salaried employee and we wanted to break it down further, we can make technically salaried employee could be abstract, and you could have like two different types of salaried employees. But then those objects would have to be whatever the derived class would be. Now, in particular, we compare employees to see if they have the same pay, even though the way of calculating pay might be different from two employees. Now, you cannot create an object of an abstract class unless it is actually an object of the same concrete descendant class. Right? This kind of makes sense here because we've already mentioned you can't make an employee object, but you can make like an hourly employee if employee was abstract. Nonetheless, it makes perfectly good sense to have a parameter of an abstract class type, such as the abstract employee. Then an object of any of the descendant classes of employee can be plugged in for the parameter. It even makes sense to have a variable of an abstract class type such as employee, even though it can only be objects of its concrete descendant classes. And that's going to wrap it up for today, folks. So I will see you all next time.